awesome. That was awesome.
NASA has found a terrifying phenomenon in Antarctica that holds the truth about our world's existence. The National Aeronautics and Space Administration has been exploring the icy continent in search of clues or any discoveries that could be buried inside the ice. They did make one spectacular discovery, and it was more than they bargained for, as this new discovery made in Antarctica is about to change everything. What discovery did NASA make in Antarctica? Could it be an alien species preserved inside the ice? Join us as we explore how NASA's terrifying new discovery in Antarctica changes everything. A lot of people don't realize that Antarctica is actually an oasis for falling rocks from space. Even most scientists were shocked to see the amount of these falling rocks Antarctica has. So far, researchers have recovered about 45,000 meteorites in it over the past century in this frozen continent. However, only about 100 of these space rocks are as heavy as the newly found meteorite, which weighs 7.57 kilograms. This meteorite is among the 5 space rocks a team of global researchers recently discovered in Antarctica. Maria Valdez, the research scientist at the Field Museum, talked about this discovery. Size doesn't necessarily matter when it comes to meteorites, she said. And even tiny micrometeorites can be incredibly scientifically valuable. But of course, finding a big meteorite like this one is rare and really exciting. Most space rocks found on Earth have come from the asteroid belt located between Jupiter and Mars. The researchers believe that the 16.7-pound meteorite found in Antarctica may have also left the asteroid belt tens of thousands of years ago. Although meteorites are composed of ancient materials and minerals, studying them helps scientists better understand the cosmos. The heavy meteorite found in Antarctica is well preserved and is even going to shed light on many unknown aspects of our solar system's history. Interestingly, most well-preserved meteorites are discovered in the deserts of Antarctica. Experts at NASA claim that apart from the already found 45,000 meteorites, 300,000 additional space rocks are awaiting to be discovered in the frozen continent. But why are there so many well-preserved meteorites spotted in Antarctica? Well, there is not one but many good reasons for that. First, Antarctica's snowy landscape, which is devoid of any native rocks, makes it easy for scientists to spot dark alien rocks in the ice. NASA's Earth Observatory even released a map highlighting different meteorite hotspots in Antarctica. Secondly, the continent mainly consists of a frozen desert with very little precipitation and arid weather, so compared to other places on the Earth, any rock there wouldn't have experienced as much weathering. Also, the continuous movement of glaciers and ice in Antarctica makes it difficult for a meteorite to stay hidden beneath the ice forever. Now, although it is relatively easy to find small meteorites in Antarctica, the occurrence of such a heavy space rock is rare and is of great importance. It wasn't an easy mission for Professor Valdez and her team, and they really had to put in some great effort to secure such a precious space rock. And their hard work started even before going on their expedition. The team's researchers observed satellite imagery showing the area's ice thickness, surface slope, and various other parameters. They even further processed this data using advanced machine learning-based algorithms. And while all of this was going on, another team making observations on Antarctica's map discovered a new satellite image that the world's most enormous iceberg, A76A, has entered the Drake Passage. The Drake Passage is a waterway characterized by a fast-moving ocean current that's capable of sending the mighty berg on a one-way trip to its watery grave. A new satellite image reveals that after slowly drifting around Antarctica for over a year and barely melting, the world's most enormous iceberg could soon be set on an accelerated course toward its eventual demise. The enormous ice slab known as A76A is around 135 kilometers long and 26 kilometers wide. This makes it the largest fragment in the world. The previous most enormous iceberg, the Rhode Island-sized A76, broke off from the western side of Antarctica's Ronne ice shelf before fracturing into 3 chunks, A76A, A76B, and A76C. The image containing this discovery was taken by NASA's Terra satellite, and scientists were surprised to see a photo of A76A floating in the mouth of the Drake Passage. This deep waterway connects the Pacific and Atlantic Oceans between Cape Horn in South Africa and the South Shetland Islands north of the Antarctic Peninsula. The image shows that the girthy berg is currently sitting between Elephant Island and the South Orkney Islands at the southern end of the passage, but its trajectory hints that it will head further north into the waterway soon. And when icebergs drift into the Drake Passage, they're quickly dragged eastward by solid ocean currents before being whipped northward into warmer waters, melting entirely soon after. A76A, however, has traveled around 2,000 kilometers since it broke off from the Antarctic Peninsula. The berg has managed to avoid substantial ice loss during its journey so far. Data collected by the US's The National Ice Center in June revealed that the A76A is almost exactly the same size as it was when it fractured from its parent berg. However, it is unlikely to remain intact much longer because the Drake Passage is known for sending icebergs on a one-way trip to their watery graves. The main reason for this is the Antarctic Circumpolar Current. It is the only current that flows entirely around the globe and contains more water than any other current on Earth. As a result, wandering bergs that enter the Drake Passage are swiftly dragged away from the Antarctic and dumped into warmer waters where they soon melt away. However, the ACC is not the only ocean current that helps determine the fate of icebergs. Other smaller currents also play a key role in the distribution and eventual destruction of the wandering ice masses, but researchers are still trying to understand exactly how. The motive for this research began when a study revealed that another record-breaking berg, A68A, which held the title of the world's most enormous iceberg for around 3 years, was ripped in half by powerful ocean currents after narrowly avoiding a catastrophic collision with South Georgia Island in late 2020. At the time, researchers were surprised when the mighty berg suddenly fractured in the middle of the ocean. Thankfully, the study revealed that a sudden shift in the direction and strength of nearby currents was to blame for the massive iceberg's breakup. Now, the most significant uncertainty in forecasting global sea level rise is how Antarctica's ice loss will accelerate as the climate warms. 2 studies led by researchers at NASA's Jet Propulsion Laboratory in Southern California showed unexpected new data about how the Antarctic ice sheet has been losing mass in recent decades. One study showed how the breaking off of ice from a glacier front has changed the Antarctic coastline over the last 25 years. The researchers saw that the edge of the ice sheet has been shedding icebergs faster than the ice can be replaced. This surprise finding doubles previous estimates of ice loss from the Antarctic's floating ice shelves since 1997, from 6 trillion to 12 trillion metric tons. Ice loss from calving has weakened the ice shelves and allowed Antarctic glaciers to flow more rapidly to the ocean, accelerating the rate of global sea level rise. And the other study published in the Earth System Science Data shows in unprecedented detail how the thinning of Antarctic ice as ocean water melts has spread from the continent's outer edges into its interior, almost doubling in the western parts of the ice sheet over the past decade. Combined, the complementary reports give the most complete view yet of how the frozen continent is changing. Antarctica is crumbling at its edges, says JPL scientist Chad Green, lead author of the calving study. And when ice shelves dwindle and weaken, the continent's massive glaciers tend to speed up and increase the rate of global sea level rise. Most Antarctic glaciers flow to the ocean, where they end in floating ice shelves up to 3 kilometers thick and 800 kilometers across. Ice shelves act like buttresses to glaciers, keeping the ice from simply sliding into the ocean. When ice shelves are stable, they have a natural cycle of calving and replenishment that keeps their size reasonably constant over the long term. But in recent decades, the warming oceans has been destabilizing Antarctica's ice shelves by melting them from below, making them thinner and weaker. Satellite altimeters measure the thinning process by recording the changing height of the ice. Still, until this study, there hasn't been a comprehensive assessment of how climate change might be affecting calving around the continent. That's partly because satellite imagery has been difficult to interpret. For example, said Green, you can imagine looking at a satellite image and trying to figure out the difference between a white iceberg, white ice shelf, white sea ice, and even a white cloud. That's always been a difficult task, but now we have enough data from multiple satellite sensors to see a clear picture of how Antarctica's coastline has evolved in recent years. For the new papers, Green and his co-authors synthesized satellite imagery of the continent in the visible, thermal infrared, and radar wavelengths since 1997. Combining these measurements with an understanding of ice flow gained from an ongoing NASA glacier mapping project, they charted the edges of ice shelves around 50,000 kilometers of the Antarctic coastline. Losses from calving have outpaced natural ice shelf growth so significantly that the researchers think it's unlikely Antarctica can grow back to its pre-2000 extent by the end of this century. In fact, the findings suggest that more significant losses can be expected. Antarctica's most extensive ice shelves all appear to be headed for major calving events in the next 10 to 20 years. And in the complementary study, JPL scientists gathered almost 3 billion data points from 7 spaceborne altimetry instruments to produce the most extended continuous dataset on the changing height of the ice sheet from as early as 1985. They used radar and laser measurements of ice elevation accurate to within centimeters to produce the highest resolution monthly maps of change ever made of ice loss. The unparalleled detail in the new record reveals how long-term trends and annual weather patterns affect the ice. It even shows the rise and fall of the ice sheet as subglacial lakes regularly fill and empty miles below the surface. Subtle changes like these, in combination with improved understanding of long-term trends from this dataset, will help researchers understand the processes that influence ice loss, leading to improved future estimates of sea level rise, said JPL's Johan Nilsson, lead author of the study. Synthesizing and analyzing the massive archives of measurements into a single high-resolution dataset took years of work and thousands of hours of computing time on NASA's servers. Nilsson says it was all worth it, though. Condensing the data into something more widely useful may bring us closer to the big breakthroughs we need to understand our planet better and to help prepare us for the future impacts of climate change. And this discovery made us know that Antarctica isn't just a big frozen desert. There's actually a lot going on under the ice. This was confirmed when scientists used IceSat, a special satellite, to discover hidden lakes of water under the ice sheet. These lakes are so deep that they're hidden at the bottom of the ice sheet where the ice meets the ground. Before this discovery, scientists thought that these lakes were all separate from each other, but to their surprise, they found out that the lakes are actually connected by water flowing between them. Sometimes the lakes fill up with water and sometimes they drain out. Eventually, the water from these lakes makes its way to the Southern Ocean. The IceSat-2 mission provided scientists with a better understanding of a network of buried lakes, including the discovery of 2 previously unknown lakes. This discovery has significant implications for glaciology, microbiology, and oceanography. Glaciologist Matthew Siegfried from the Colorado School of Mines describes the discovery of these interconnected lake systems as a major breakthrough from the IceSat mission. IceSat-2 is like putting on your glasses after using IceSat. The data is so high precision that we can really start to map out the lake boundaries on the surface. A recent study conducted by Siegfried and his team analyzed data from IceSat-2 and the original IceSat mission, as well as measurements from Cryosat-2, a satellite that observes ice and is operated by the European Space Agency. The researchers merged datasets from 2003 to 2020 to keep track of active subglacial lakes more frequently than IceSat-2, which has a 91-day gap before it can observe the same area again. Surface deformation due to active subglacial lakes filling and draining provides one of the few remotely accessible windows into the evolution of basal water systems. These systems are otherwise hidden beneath up to 2.5 miles of ice and remain one of the major physical uncertainties on projections of future ice sheet dynamics, the researchers wrote in their study. The use of IceSat-2 laser altimetry can help us learn more about subglacial lakes and hydrological processes. It can also provide more detailed and accurate spatial information. Also, the analysis not only provided us with a more comprehensive understanding of the behavior and shapes of the subglacial lakes in Antarctica, of which there are already more than 130 known, but it also revealed 2 anomalies that seem to be concealed lakes that were previously unknown. The 2 lakes, Lower Conway Subglacial Lake and Lower Mercer Subglacial Lake, were located near other previously discovered lakes but were not seen immediately. They could have been missed because they were in the narrow gaps between observations. The region beneath the Mercer and Whillans ice streams in West Antarctica has a lake system dominated by two large active subglacial lakes, Conway Subglacial Lake and Mercer Subglacial Lake. This lake system appears to be experiencing its third drainage event since ISAT observations began in 2003. Now, recently, glaciologist Helen Fricker from the Scripps Institution of Oceanography co-authored a study about a dramatic lake drainage event in East Antarctica, where a surface lake on a floating ice shelf disappeared in just a few days. Now, the water drainage from subglacial lakes in West Antarctica is believed to eventually flow into the ocean, but the exact route is difficult to visualize. These are processes that are going on under Antarctica that we wouldn't have a clue about if we didn't have satellite data, Fricker says. We've been struggling with getting good predictions about the future of Antarctica, and instruments like ISAT-2 are helping us observe at the process scale. Now, we thought that was all with the lakes until NASA scientists made another announcement about discovering two new lakes hidden beneath the Antarctic ice sheet. These lakes are part of a large network of underground waterways that are concealed under 1.2 to 2.5 miles of ice. And the lakes have a peculiar characteristic of continuously filling and draining in cycles that are not yet fully understood. These cycles may have an impact on the speed at which ice sheets move and the path that meltwater takes to reach the Southern Ocean, and this process is crucial for the global ocean circulation. Study leader Professor Matthew Siegfried, a geophysicist at the Colorado School of Mines, said, "It's not just the ice sheet we're talking about. We're really talking about a water system that is connected to the whole Earth system." And in 2003, NASA's ISAT mission helped uncover a water system located at the bottom of the ice sheet. Scientists analyzed data and discovered that changes in ice elevation in West Antarctica indicated a large amount of subglacial water movement beneath the ice sheet. Previously, it was believed that hidden meltwater lakes existed in isolation from each other. However, in 2007, researchers found that fluctuations in the height of Antarctica's surface ice indicated the movement of water flowing between a network of subglacial lakes. These lakes alternatively fill and drain before their water escapes to the Southern Ocean. This was beyond intriguing, so a team was sent there to do some experiments, and it was there a couple of NASA scientists found evidence of a parallel universe where the laws of physics are opposite to our own. The idea of a parallel universe has been around since the 1960s, but now a cosmic ray detection experiment has found particles that could be from a parallel realm that was also created during the Big Bang. The scientists used a giant balloon to carry NASA's Antarctic Impulsive Transient Antenna high above Antarctica, where the dry air provided the perfect environment with a little radio noise to distort their findings. The ANITA detected heavier particles called tau neutrinos, which come up out of the Earth, suggesting that these particles are traveling backward in time and providing evidence of a parallel universe. Peter Gorham, an experimental particle physicist at the University of Hawaii and the lead investigator of the ANITA project, has suggested that the tau neutrino could only behave in a certain way if it transformed into a different type of particle before passing through the Earth and then back again. Gorham and his team have observed several of these impossible events, which some have been skeptical about. The simplest explanation for this phenomenon is that during the Big Bang 13.8 billion years ago, two universes were formed, ours and one that appears to be running in reverse with time going backwards. However, if there are inhabitants in this parallel universe, they would consider us to be the ones going backwards. We're left with the most exciting or most boring possibilities, said Ibrahim Safa, who also worked on the experiment. The researchers used a new method to find meteorites in Antarctica, which helped them identify the best locations to search for the most meteorites. This is the first time this approach has been used. They spent 1.5 weeks exploring the frozen continent in very cold temperatures of -10 degrees Celsius. When they returned, they had found 5 new meteorites, including a rare 16.7-pound space rock. Going on an adventure exploring unknown areas is exciting, but we also had to deal with the fact that the reality on the ground is much more difficult than the beauty of satellite images, said Vincian Debai, one of the scientists who went on the meteorite mission. Currently, all the meteorites that have been recovered are being examined at the Royal Belgian Institute of Natural Sciences. Despite the National Aeronautics and Space Administration making many new discoveries, they have not found a parallel universe, though, where time runs backwards. Instead, scientists have discovered some unusual results from high-energy particles in the Antarctic that challenge our current understanding of physics. The lead author of the paper, published in the Astrophysical Journal, Ibrahim Safa, stated that these events cannot be standard neutrinos and may be due to our limited knowledge of the Antarctic ice. However, this does not mean that time is running backwards or that a parallel universe exists. In 2016, the Antarctic Impulsive Transient Antenna (ANITA) detected high-energy neutrinos coming out of the ground, which had already traveled through the entire planet. Many theories were suggested to explain this strange signal, but a recent study ruled them out. However, the possibility of a parallel universe created in the same Big Bang as our own was suggested as an explanation. Scientists analyzed 8 years of data to try and solve the mystery, but the only conclusion they reached was that the standard model is not enough to explain the observations made by ANITA. This suggests that there may be physics beyond the standard model. It is unclear where these high-energy particles came from, but it is not necessarily a parallel universe. And what are ANITA and its connection to NASA? ANITA is a tool used to detect neutrinos, which are tiny particles with no electrical charge and very little mass. Neutrinos are abundant in the universe, but they are difficult to track because they interact very little with physical matter. ANITA is a NASA observatory that flies a balloon over Antarctica with radio antennae pointed to the ground to detect neutrinos. And despite their elusive nature, scientists are determined to find ways to detect neutrinos, and ANITA is the first tool of its kind to be used by NASA. This means more missions will be carried out to truly confirm this idea of a parallel universe, and we cannot wait to see what these experiments hold. However, we can't be too certain about the results. But what do you think about these discoveries made by NASA? Let us know in the comments section below.